Hi guys, welcome to week 8 of the project analytic course. Today we'll be discussing about predictive analytics, which is one of the key components of project analytics and decision making. Predictive analytics, what is predictive analytics? It focuses on using historical data to make informed projections or predictions about future outcomes. And in project management, this is extremely valuable because it allows us to anticipate risks and estimate timelines and forecast costs and improve overall performance of the project. Well, throughout this session, we will explore what predictive analytics is and how it works, and any different techniques used, including classification and some of the regression model, pretty much your correlations or linear regression and multiple regressions. We will also look at very real world applications and examples to help you understand how these techniques and are applied in practice. By the end of this course, you should have a solid understanding of how predictive analytics is used, which can be supported for better decision making in project and business environment. This is your course module. So far we covered the foundational topics such as data basics we did on week 2. Week 3 we did basic analytical tools, descriptive analytics in week 4, and diagnostic in week 5. These helps us understand what has happened and why it has happened, particularly in data analytics. And last week we had data visualization and dashboard. We learned about Power BI, which helps represent how you can produce visualization, how you can import data, and how you can use DAX, which is kind of a formula used in formula function used in Power BI. And this week we move on to predictive analytics, which probably answers the question what is likely to happen next. In coming weeks, you'll also learn about prescriptive analytics and some automated tools, which can even go further by recommending actions. So, predictive analytics is a critical transition point for understanding the past and forecasting the future. So, what is predictive analytics? Predictive analytics is all about using historical data to identify patterns and trends. Once we identify these patterns, we can use them to predict future outcomes. For example, if you analyze past project delays, we may identify patterns that help predict whether a current project is at risk of delay. This approach is widely used in many industries such as finance, healthcare to marketing and engineering. The key idea here is that past data contains some valuable signals which you can utilize to do some different action in the future. If we analyze it correctly, we can make informed prediction rather than relying on intuition alone. Once patterns are identified, they are represented using a couple of mathematical models. These models act as a tool that makes or takes input data and produce prediction. For example, if you build a model using past sales data, we can use to predict the future sales based on current trends. The strengths of predictive analytics as of these models. They allow us to process large amounts of data and generate insight that would be difficult to obtain manually. In simple terms, the model learns from the past data and applies that learning to new situations. Predictive modeling techniques. There are two main types of predictive modeling techniques. One is classification and one is regression. Classification is pretty much used when the outcome is categorical. For example, yes or no, true or false, or proved rejected. An example is predicting whether it will rain tomorrow or not. That's a classification. Regression, on the other hand, is used when the outcome is numerical. For instance, predicting stock market or project cost or revenue. Understanding the difference between these two is quite important to because it determines which modeling techniques you will be using or you should be used for a given problem. Classification technique. There are several classification in predictive analytics. Some of most commonly used is in the list shown in the slide. The first one is decision tree, the random forest, support vector, k, K nearest neighbor, and neural network. Each of these techniques has its own strengths and weaknesses. For example, we look more on decision trees. Decision trees are easy to understand, while neural networks are more complex but powerful. In practice, the choice of techniques depends on the nature of the data, the complexity of the problem, and the level of accuracy which you are required for your project. Where is it used? Where can predictive analytics can be used? In finance, they are used to predict stock market, as I said before, stock price movements or credit approvals. In marketing, they apply to identify the next best product to offer to your customer. In web analytics, they power recommendation systems like customers who this also bought a different product. In healthcare, they can predict disease outcomes and treat effectiveness. Even in social science and politics, classification models can be very much used to predict election result. These examples show how powerful predictive analytics can be used in the real world decision making process. So we focus on decision making or decision tree. Sorry, if you look at decision tree, it is one of the simplest and most intuitive classification technique. It works like a flow chart where each decision leads to another branch until a final outcome is reached. We start with the root node, which is your basic node, which represent the initial decision point. Then the data is split into branches. We call it child node, based on certain condition. Each split creates new nodes, and the process continues until it reaches the final decision, which is also known as leaf node. It's just like a tree. Think of a tree starting from the root. It goes through branches, it goes through the trunk, it goes through branches, it goes to the end of leaves. This structure makes decision tree easy to interpret, explain, which is why they are widely used. You see a short example, making on think of you want to go for a vacation. If it's yes or no, there can be two answers, and that becomes your terminal node. And if you say yes, whether it's going to be low cost or high cost, that becomes your sub node, and it keeps going on. It's also called child nodes of yes, and can also go further depending on what level you want to go for. So that's your decision tree example. Okay. This slide shows a data set used to build a decision tree. We have variables like outlook, temperature, humidity, windy, play tennis, and the outcome is whether you want to play tennis or not. So that's what you're going to determine. The goal is to identify patterns in this data. For example, under what condition do people decide to play tennis? We group the data and analyze how each factor influence in final decision. This is a step-by-step process helps us to build the structure of decision tree. It's pretty much the same thing. You look at humidity, you're focusing on identifying the first factor. You group the final decision, and you got to look at the second factor, and then you got to group the final decision. So it then keeps on going and determine whether you want to play your tennis or not. So in this case, if the humidity is high, you probably don't want to play for it. And you got to look at you got to look for windy. If it's weak, then yeah, probably we can play. If it's strong windy, so you don't want to play. So what is the first factor you want to look? So you're looking at humidity, and what is the second factor you look is windy. So you've got to make a decision based on the factors. So in this diagram, it visually represents the decision tree from a data set. You can also see how the root node split into branches based on condition like outlook, for humidity and windy. Each path leads to a final decision whether you want to play tennis or not. This is a visual representation, make it easier to understand the decisions are made by step by step. Okay, let's see how to build a decision tree. Building a decision tree involves selecting the most important attribute first. Which attribute you are going to focus on? We use numerous measures in like information gain or impurity to determine which variable best split the data. Once we select an attribute, we divide the data into subset based on its value. We then repeat this process for each subset until the data is perfectly classified or no further improvement can be made. So this regression process continues until the tree is fully developed. So in this exercise, you will apply what you've learned to build your own decision tree. You analyze the data set with the variables like age, income, student, and its credit rating, and you determine whether someone will buy the computer or not. The goal is to identify the most important factors and construct a logical design structure. This hands-on activity will help reinforce your understanding of classification and decision tree. And it's again, you look at your age, look for the students, you go into the credit rating. Is he a middle age? Is he going to be a youth? If it's youth, is he a student? Yes, no. And if it's a middle age, yes. And if it's a senior, and is it credit rating fair or excellent? And you decide based on that. So now let's look at the second classification, which is your regression type, which is used for predicting numerical values. Regression investigates the relationship between an independent variable and an independent variable, which we already saw in week 4 or week 5. Regression examines the relationship between the dependent variable and one or more independent variable. For example, we predict project costs based on factors like duration, resources, and complexity. Regression is widely used in forecasting and trend analysis, making it a key tool in predictive analysis. So in regression, we are going to see two types. One is linear and the other one is multiple regression. Linear regression is the simplest form of regression. It establishes a relationship between variables using a straight line, often called line of best fit. So as you see in your diagram there. So the equation includes an intercept, a slope, and an error. By fitting data to this line, we predict future values. For example, predicting sales based on advertisement spent. So what is multiple regression? So multiple regression extend this concept by including multiple independent variables. Instead of just one factor, we consider several variables that may influence the outcome. So if you look at from a project perspective or project cost could depend on the labor, materials, time, and risk factor. This produces a more realistic and accurate model for complex scenario. So the important point here is you need to have some assumption and limitation. First, there should be a linear relationship between variables. Second, issues of multi-collinearity or autocorrelation or hydroscedasticity can affect model accuracy. Also, regression model also sensitive to outliers which can distort your result. Understanding these limitations is crucial when applying regression in real-world scenarios. So that brings us to the end of the session. We covered the fundamental of predictive analytics, including classification, decision tree, and regression testing. I'll be more than happy to take any questions. If you have anything, please raise it, or I'll explain it in the class. Thank you guys. Have a good evening.